The year was 2001 when NASA's Mars Odyssey began its historic journey, a mission that would redefine humanity's understanding of the Red Planet. It was not the first spacecraft to explore Mars, nor would it be the last, but what it uncovered changed
Please subscribe my YouTube channel and press the bell icon for new updates.
the course of planetary science forever. From discovering vast amounts of subsurface ice to mapping the planet's radiation environment, Odyssey became the silent sentinel of Mars, orbiting relentlessly, transmitting data, and reshaping our knowledge of a world once thought barren and lifeless. At the time of its launch, expectations were high but measured. Scientists hoped for clues about the planet's history, potential habitability, and geological secrets buried beneath its rust-colored sands. But Odyssey would go on to exceed even the most ambitious hopes. As it circled Mars, peering deep into its mysteries, it relayed back findings that not only altered scientific models but also paved the way for future missions, including the Curiosity and Perseverance rovers. One of Odyssey's greatest revelations came early in its mission, the detection of water ice beneath the surface. Using its gamma-ray spectrometer, the spacecraft identified vast amounts of hydrogen, a telltale sign that frozen water lay just beneath the Martian soil. For decades, scientists speculated about the existence of water on Mars, but Odyssey provided the first hard evidence. This discovery sent ripples through the scientific community, fueling debates about whether Mars once had oceans, rivers, and possibly even life. As the years passed, Odyssey's instruments continued to work tirelessly, mapping the radiation levels on Mars, a crucial step in preparing for human exploration. Radiation was one of the biggest challenges for any potential manned mission, and Odyssey's data helped scientists understand the risks astronauts would face. The mission revealed that Mars was bombarded by cosmic rays and solar particles, far beyond Earth's protective atmosphere. This information played a key role in designing future spacecraft and habitats that could protect human explorers. Beyond radiation and water detection, Odyssey served another critical purpose: mapping the Martian surface in unprecedented detail. The spacecraft's thermal emission imaging system, THEMIS, provided stunning infrared images of Mars, uncovering volcanic plains, deep canyons, and hidden valleys that had never been seen before. Scientists now had a treasure map of the Martian landscape, highlighting regions of interest for future landers and rovers. One such region was Gale Crater, a site that Odyssey's data suggested once held water. This information would later influence the choice to land the Curiosity rover there in 2012, where it found even more evidence of ancient water flows. Odyssey's detailed maps also played a role in selecting landing sites for Perseverance in Jezero Crater, where signs of an ancient river delta pointed to a time when Mars might have been a thriving, wet world. Despite being a long-lived veteran of the Martian skies, Odyssey continued to provide vital communication support for newer missions. Acting as a relay station, it transmitted signals between landers and Earth, ensuring that every new discovery made on the surface could be sent back home. Without Odyssey, the transmissions from Curiosity, Insight, and Perseverance would have been weaker and less reliable, proving that Odyssey was not just an explorer, but also a lifeline for Mars missions. The spacecraft also helped settle some long-standing Martian mysteries. One such puzzle was the source of methane on Mars. Scientists had detected traces of the gas, which on Earth is primarily produced by biological activity. Could this mean Mars harbored microbial life beneath its surface? Or were geological processes at work? Odyssey's observations helped refine our understanding of Martian atmospheric dynamics, though the mystery of methane's origin still lingers. Even as newer and more advanced missions arrived, Odyssey remained a cornerstone of Mars exploration. It stood as a testament to the brilliance of engineering and the endurance of human curiosity. Initially designed for a 4-year mission, it far exceeded expectations, operating for over 2 decades. As it continued to orbit, its fuel slowly dwindled, and scientists knew that one day its transmissions would cease. Yet even when that day comes, Odyssey's legacy will live on. The maps it created, the water it found, and the radiation levels it measured have shaped every Mars mission that followed. It proved that Mars was not just a dead rock in space, it was a planet with a complex history, a dynamic environment, and perhaps the potential to support life in some form. As future astronauts step onto the Martian surface, they will walk paths first charted by Odyssey. The spacecraft that once seemed like just another mission will be remembered as one of the most important in Mars exploration history.